Okay, so now we're looking at using the differentiation to find gradient. So the question is, find the equation of the tangent to the curve with equation y equals x cubed minus 2x at the point where x equals minus 1. So the first thing you're going to do is you're going to use differentiation to find the gradient. Once you've done that, this is just a National 5 question basically. So remember that if you've got a curve and you're finding a tangent at a point, that is the line that has exactly the same curve, exactly the same gradient as the curve at that point. So that is, in this case, at the point x equals minus 1. So we need to find the gradient at x equals minus 1. We're also going to have to use the original equation to find the y coordinate at x equals minus 1. And once you've done that, you've got the gradient of the line, you've got a point on the line, you can find the equation of the line. So we've got y equals x cubed minus 2x. That is nicely ready for differentiation. We don't have any preparation to do. So we're going to say dy by dx equals 3x squared, because you're multiplying by the power and reducing the power by 1, minus 2. Okay, so that is a general equation for the slope, for the gradient at any point on our curve. But we want it at a particular point. We want it where x equals minus 1, and that is the gradient of our line. So m, the gradient, equals this equation. But we've got a negative, so we definitely want to put brackets around it because we're about to square it. Minus 2. So that's 3 times minus 1 squared minus 2. So minus 1 squared, that is minus 1 times minus 1, which equals 1. A negative times negative will give you a positive. So it's 3 times this thing is 1, so that's 3 minus 2, which probably equals 1. There we go. Now we have a gradient. So that is the slope of our straight line. We've got an x coordinate. We know that x equals minus 1, but we need a y coordinate. And this says y equals, it's going to give us a y coordinate. So y equals x cubed minus 2x, and into that we are going to substitute our x coordinate. So minus 1 needs to be in brackets, we're cubing it. Minus 2 times minus 1. Okay, minus 1 cubed is minus 1 times minus 1. Well, that would give us 1 times minus 1. Well, 1 times minus 1 is going to give us a negative 1. So that's negative 1, and then negative 2 times negative 1, that's a negative times a negative. The signs are the same, so you're going to get a positive, and 2 times 1 is 2. Negative 1 plus 2 is 1. So what we have now is a gradient of 1, an x coordinate of minus 1, a y coordinate of 1. So y equals mx plus c. Y equals 1, m equals 1, times minus 1 plus c. 1 equals negative 1 plus c. So that means if you added 1 to each side of those, that's 2 equals c. So our final equation is y equals, and then we need to put the gradient in because it's 1, so it's 1 times x, which is just x, plus our c, which is 2. And that's the final equation. Okay, next question. The curve has equation y equals a third x cubed minus a half x squared. Oh, you can't see that. The curve has the equation y equals a third x cubed minus a half x squared plus 2x plus 5. And we've got to find the coordinates of the points on the curve where the tangent has a gradient 4. So we're going to take that, we're going to differentiate it, and then we're going to say, well, at the point that we're interested in, the gradient equals 4, so the differential equals 4. So let's do that and see where it takes us. So we've got y equals 1/3 x cubed minus a half x squared plus 2x plus 5, and we're going to differentiate that, and that's 3 times a third is just going to give us a whole, and reduce the power by 1 is squared, minus 2 times a half gives us just 1 again, so it's just minus 1, and then reduce the power by 1, so x. Differentiating that will just give us a 2, and that disappears entirely. So dy by dx equals x squared minus x plus 2. Now that is the equation for the gradient at any point on the curve, and we're told that we want the point on the curve where the tangent has a gradient of 4. So we want the point where that thing that we've just worked out equals 4. So let's make it equal 4. So now we've got x squared minus x, and if we take away 4 from both sides, that gives us minus 2 equals 0, because that's a quadratic equation, and to solve a quadratic equation you always want to make it equal to 0. Then to solve a quadratic equation you need to factorise it. So x squared minus x minus 2 equals 0. To factorise that, I'm going to have an x at the start of the brackets. I'm looking for things at the end of the brackets. They're going to give me 2. Well, 2 is a prime number, so it's going to be 2 and 1. It doesn't actually matter where they go because both of these were x. And it was negative 2, so one of these brackets has to be positive and one of them has to be negative. But I want a middle term of negative x. So I'm wanting the negative to dominate. I want the bigger term to be negative. So I'm going to make that negative 2 and positive 1, and I'm just going to check those middle terms. So negative 2 times x gives me negative 2x, and x times a positive 1 gives me plus x. If I add those together, that gives me minus x, which is what I wanted, so I'm happy. Okay, so I know that x minus 2 equals 0, or x plus 1 equals 0. So I'm going to say that x equals 2 or x equals minus 1. Now I've got the x coordinates of the points I was asked for. So it said find the coordinates of the points on the curve where the tangent has a gradient 4. So we're expecting 2 points because it said the coordinates of the points. But I've only got the x coordinates at the moment. I'm going to have to get the y coordinates by substituting into this equation. So I'm going to take each of these in turn and I'm going to substitute them in. So I'm going to say, okay, if x equals 2, well, we had an equation for y, it's here. Y equals 1/3 x cubed minus 1/2 x squared plus 2x plus 5. So if I put x equals 2 in there, y equals 1/3 times 2 cubed minus 1/2 times 2 squared plus 2 times 2 plus 5 equals 1/3 times 8 minus 1/2 times 4, which is just 2, plus 2 times 2, which is 4, plus 5. So 8/3 minus 2 plus 4 plus 5. So that's 9 minus 2 is 7, so plus 7. And 2/3 plus 7 equals 9 2/3. So the first point I've got, that's the x coordinate, that's the y coordinate. 2, 9 2/3. You can do that on a calculator if you want, assuming it's a calculator question. And your other point, well, it's still the same thing. Y equals a third x cubed minus a half x squared plus 2x plus 5. And we're going to put in the other x value we had. So we had the other one was x equals minus 1. So it's 1/3 times minus 1 cubed minus a half times minus 1 squared plus 2 times minus 1 plus 5 equals 1/3 minus 1 cubed is just minus 1, and minus 1 times a third is just minus 1/3. Minus a half times minus 1 squared, well that just gives us 1, so it's minus half times 1, which is just minus a half. 2 times minus 1 is just minus 2, and plus 5. So we're going to have minus 2/6 minus 3/6. And then minus 2 plus 5 is going to be plus 3. So we've got a plus 3 and then minus 5/6.